Hi everyone. So today we're going to start by talking about what outcrops are and what unconformities are and why they're relevant to earth science. So outcrops are the part of a rock formation that appears above the surface of the surrounding land. Basically is just a higher land area next to flatter land area. And if you would like, you have the option of writing this definition down in your notebook. And this is helpful for geologists because when rocks are lifted up like this, a lot of times we can see the sedimentary rock layers that have been formed over time, and that can help us date rocks and find its history. And outcrops are often used by geologists and paleontologists to find fossils and study the geological history of rocks. So, say this is an outcrop. As you can see, there's many layers of sedimentary rocks that have built up over time, and this rose up through crustal movement, such as plate tectonics. And a lot of these layers may have shells in them, different types of rock formations, and fossils that scientists can use to date rock layers. So, how does an outcrop typically form? Well, first, the sedimentary rock layers are deposited over time, and then because of plate tectonics, the crust can move, and it can move upwards sometimes, like this diagram. And then after it moves, and this takes a long period of time, over time, weathering and erosion can erase away the very top layer. Say through wind, a lot of times through wind, actually, wind can carry these particles away. Um, to form a flatter surface on the top, and this can lead to what we call an unconformity. An outcrop. Another thing or another structure is called an unconformity, and this is what an unconformity is. Based on how the rock layers are shown or sequenced, how do you think this unconformity formed? Why is it shaped like this? Think about it, pause the video, discuss with the peer, and come back. So, unconformities form in a very similar way to outcrops, as we've seen. So, for an unconformity like this to form, we still have deposition of sediments to form sedimentary rock layers. There is uplift from plate tectonics still. There is weathering and erosion on the top, as usual, like an outcrop. But afterwards, over time, we deposit even more sediments to form even more sedimentary rock layers on the top. And that's what happened here. And this is what we call an unconformity. So the sedimentary rock layers were deposited, there was uplift. That's why it's kind of crooked over here. And that's actually an evidence that we can see that crustal movement happened. And after that, there was erosion on the top, maybe over here, and then more sediments were deposited. That's why it's kind of a weird shape. So take out your note packet and write this down. An evidence of crustal movement. Remember, original horizontality is when rock layers are originally deposited flat. That's our law. But how we know that the Earth's crust moved is by the tilting of rock layers, kind of like you see over here, and through unconformities. This is an unconformity. And they happen through deposition of sediments, uplift from plate tectonics, and then weathering and erosion. You do need to memorize this. It's asked a lot on the earth science regions. So go ahead and pause this video, write this down. So the thing about this unconformities is, since after uplifting, we've deposit sedimentary rock layers, it uplifts, and then weathering and erosion sort of erases some of the rock history, and then new sediments are laid down. So sometimes there can be an erasure of rock history in an unconformity, but a different unconformity or a different outcrop nearby can have different rock layers, just because those rock layers have not been erased yet, just like this conformity here. You'll see an example later when we talk about this more. So when we look at diagrams, normally unconformities are represented through these squiggly lines. So when you see these squiggly lines, you know it's a nonconformity, and this is a helpful hint to show that maybe some rock layers have been erased. Some rock layers are missing because this is an unconformity and their weathering and erosion has happened. So you can see that these are curvy sediments, just like how it was uplifted in this unconformity, and then the top was erased, and then new sediments were deposited on the top. So remember some three pieces of evidence that you can use when you're asked about, okay, how do you know what's the evidence you have to see that there's crustal movement that happened here? You could say that the image does not follow the principle of original horizontality, meaning rock layers are originally deposited horizontally or flat. You can also say the tilting of rock layers. The tilting of the rock layers is evidence that it moved, or you can just say unconformities. You can choose one of these three. So, and you can also find this in your notes. It does not follow the principle of original horizontality. So, in the next video, you'll find the practice questions. That's it for now.